continue go to the number 4 subchapter of this semantic web, RDF, and linked data SPARQL, the number 2 chapter. This chapter we will talk about reusing and creating vocabulary. So compared to the earlier, we talk about URI, URL, distinguished with IRI, which we are most used in our ontology as the identifier, and also last several videos we talk about RDF, which is the key components within the SPARQL. RDF represent on this R character. And now we are talking about the vocabulary. So within this subchapter, we try to do some, I've distinguished this into 3 small parts. First, the small part is the RDFS, RDF schema, and all. So because RDF is based on the all language, adding a type mechanism to classify subject and object. So we will talk about some the online vocabularies that you can leverage, and also we try to use this number 42 turtle to show you how those vocabularies are being used. And then the RDF schema itself is our vocabulary we should treat with our schema whose triple declare facts. So that means you can do the query to the RDF schema same as the RDF. So we will use 3 samples to show you that. And without defining a large complex ontology, many RDF developers use just a few classes and properties from all and add metadata to their own the triples. So that is the 46 mentioned. So if you come to this book, actually is the content is in the page 36. So we can start to use that. And in the first paragraph, author mentioned the FOF and the Dublin Code, who are 2 the famous online existing vocabularies. So I also, if you come to the mind map, I also give you the link here. So if you through the link and it go to this online ontology, so those I put some link back to this chapter 1 and here. So you can click the FOF. Then you go to this XML namespace.com for specification. So here you can have the vocabulary. Now it's the 0.99. And if you click this RDF, actually you are going to see those specification in the this below detail. Similarly, is if you click this Dublin Code, so you go to this Dublin Code's the websites. Here also have this specification, so you can see the code specification or code schema specification. So from here you can also keep reading that. Is they have the RDF schema representation, so they have certain the different RDF that you can keep reference. Let's do those samples altogether. So first, let me create our 0204 chapter. So with this file ex042.ttl. So what's this one means? So it means that here's a few triple from RDF schema vocabulary described within the Dublin Code. So if you come to here, it's a DC, is the Dublin Code namespace. They describe the term creator. So we have our creator term, and which we can use to describe a person relation to the book. So the person is the famous person, Tim Berners-Lee. So let's do this. So we add the prefix. It's DC, is Dublin Code. You just use the space. It's fine. So or you can use tab. So here is this DC. So if you come to here, you can see you can also get certain those namespace to get load to your the Dublin codes the schema. So those are the things you can see here. This schema defines terms of a simple Dublin code. So this is what we are putting here, DC elements 1.1. So you can refer to those online parts. And then second one is the RDF, and the third one is RDF schema. So we add them. You need to have the pound in the last with the period, but for Dublin code we don't have that. And then we can make this creator as the subject. So that is one, and we can have a space with the RDF type, with the space RDF property. With a space with the semicolon, so then that means you will reuse the same subject and just have the predicate and the object difference. So we can have this put in here. Here I will mention that later is our small case A. You may see this the same. The RDF schema comments. So we learn this, and we also have RDF as a label. So comments. After these double quotes, you have this add, and from here you can have the language tag. This label is the same. After the double quotes, you have the add is the language tag. So ensure the country is the all capital. And let me copy this one. So copy our wild query to our folder. So let's see. So we use arc data. Data is our EX042 TTL. Query is RQ. So let's try to do the query. So we create 3 triples. So you can see here the subject are all same, and one is this type. Type is this one, property, and second is RDFS schemas comments. Third is label. So we have this object contents here. So the last 2 triple describe one URL and property and with the comments, and one this creator name with the label. So and we put that into the American English. The first triple use a property we haven't seen before. So this is the RDF type. But we can just have look is if we comment this one and uncomment this. Now let me run this again. You can see you get the exact same result. So that is the effect of this short A. So in Turtle, N3, and SPARQL, with this shortcut, not all. So bear in mind is using this word A instead of RDF type in a triple because it's quite like our the plain language in English. C is a property, so we just short cut it as RA. But just this is the only one we used A, and this is the only case sensitive part in SPARQL. You cannot use capital A. So that is this RDF as schemas. In itself is a vocabulary, so we already showed the comments and the label. So now let's say in addition to identify property, RDF schema lets you define new class. We can define our own class. So those are the existing class. So label and the comments. So let me open also our the normal, the property. So if I put that here, so if within this entity, so you can see here. So if I don't create anything on this annotation, you can see here, there's several RDFs. So we use these comments and label, and also is defined by, they also are the RDFS schemas vocabulary. Later you may say all. All also have something is like version information, backward compatible with, depreciated. So all of those vocabularies actually you can read from this RDFS schema specification. So, but beyond that predefined, those vocabularies, let's use this 43 to create our own this vocabulary. So EX043. So we will use our two same. So let me copy these two. And then add one is our address book. In earlier video, we mentioned that this just our URI or IRI, so you can also refer that to our local, whatever the link to show you this namespace that is predefined by you. So this is not our web page, not URL. So try to distinguish that. We will define two. So one is the musician, another is a musical instrument. So these are the two vocabulary or those subject that doesn't exist in the predefined RDFS, but we can define that for our own usage. So one of these, and then this we can put that here, this RDF type. Remember is we can use A, so we will use A here. So the type is our RDF schema class. So that means is you can use RDFS vocabulary also as the object. So then RDFS label is the musician. Someone who plays. Ensure you have the period in the last line so that you can close this group of the triples. See, as RDF type, we use A. Also our class. So this class means what? So if I create the test, so you can see here. So this is our class. So type is the class. Let me see here. Entity RDFS type. So if I put in here, so the class count is 1. So that is the class, and which means it's like this RDFS vocabulary. We just give a label, so it's a period. We didn't bother the RDFS comments for musical instrument because this sort is defined by itself, so the label is enough. Now let's try to query this. So like query this 43. I should have 5 triple. So now you have a musical instrument. You don't need to worry about the order. So in the triple within our RDF, there's no predefined order. So this can be shown earlier than this musician. So you have this type is a class. So now here is the complete URI is this one. So we use RDFS and then the class. And same as this number 3, the triple musician is a class, and then we have 2 labels and 1 comments. So those are this sample. So you can define your own the vocabulary. There's a lot more metadata that we can assign when we declare a class. For example, one class can be a subclass of another. So in the the prodigy is quite clear. So you can see description for test. You can define the subclass. So I define our AAA, for example. So I put that is you can see this one is subclass to test, and every class is a subclass to the root thing. So that is not showing here. But if you create a subclass, they have this one. And actually the vice versa test is the superclass of AAA. So that is the inverse relationship. So subclass is just another one. But with just the metadata above, we can have another nice feature of RDFS. Below is we define the play instrument property. So we still just in this learning SPARQL book, but if you have these tangible things, you may see here. So within Prodigy, you have the class, you have the object property, you have the data property, you have even the annotation property. So if you define our object property, you have this T as a property. You can see here, later on we will see you have this domain and the range and the disjoint super property of or sub property of. So property is another domain of the things that we can define. But now let's use a triple to define the property. So starting from 44. I expect that you can follow me. Even you can read this, but don't try to copy paste of my code. Let's do the typing together, because during the typing you may see the difference effect of every line. For example, when we load Dublin code, you may notice this, you don't have this pound in the last, but you can use that. So that is the distinguish of certain tiny things of our code. So try to use as much as possible to try to find out any typo if you learn from your mistake. But for this 44, I just directly copy this the 43. But when I copy this, you may see here, I actually have some arrows. Here should be the namespace, not X. So even if I don't create any arrows, but actually I just do our simple query. But if you are starting to try to combine some more the information analysis, this type of arrow may generate some the different results. So during this typing, you may also have chance to learn the syntax by the more tangible things. So try to follow me to type yourself. So now is we define a name of the property with play. So when you read this play instrument property, then that means from the plain language in English is somebody play some play instrument with our musical instrument. So the subject should be our musician, and the object should be our the musical instrument. So that is our the real usage the triple for this property. But when we define the property, we also need to think about is what inside those properties. So we have this RDF first type. We can use A actually. So it's RDF property. It's not RDFS property. So first we define this as a property. It's actually is an object property, and RDFS comment defines the instrument that someone plays. So let's back to here. So first is within the 42. So let me also create our new file. I can show you like something like this one. So when we have our turtle or triples, let's see here. When I put this here, if I make this as our name, so 0204, we have starting to list down certain triple. So let me save this as our 0204 first. I will move that to our folder within our file. And then let's try to practice immediately from here. So we go to the entity, we go to the class. So here, the number 42, we don't create that. But here, we create our two class, right? So one class, let me see here. What I show you here is the musician. That is the visualized things. The second one, it doesn't have a relationship with the musician by default, so we create that as the sibling class. It's a musical instrument. So we have two classes. It's reflect on these two triple. And the first class musician, we have our label. So when we click this annotation, you come to label. Then label is a musician. So you click here, then you can see the RDFS label is here. Keep adding the comments. RDFS comments, someone who plays. So now you have the comments, same as the, so I need to rename that musical. Yeah, within the Prodigy, if you want to do the rename, you use the Control U. So then that is the same as here. So Control U, I think is here. Where is that tool? Reason view. Refactor, here is this one, rename entity. I just use our shortcut. Now let's go to our musical instrument, So you can see this is reflect what we did on this exercise 43. So what we are doing now is on the exercise 46. So let me save this again. Choose a format. Let me see. So active. I already saved. Choose a format when you use. The following have changed outside the property. To reload. Reload this one. Oh, I didn't change that outside. So that is interesting. Let me retype. So let's do this property definition, then we reflect that into the property. So RDFS label is place instrument is a semicolon. RDFS. These are two new domain. This predicate musician RDFS range is address book. With a period. So what this means in the property? So we have one musical instrument. So I think this we should do musical instrument. And then these are the musician, the musical instrument. So we don't have that period in the middle. And here showed is the label. Let me go to the object property to create our property called play. It's using the camel. So the first is the small case, and from the second words, the first letter is the capital case. So this is the property. They have our type is the property by default, comments. Let me copy this. Okay, now we have the property comments. Now let's the label. And then here is the domain is actually here. So intersection. Domain is a selection, so you can select from the class hierarchy. So domain is you point to what's your class defined, so it can reach the musician. It's not a free text. And then when you click back to the play instrument, we choose the range. Range is the instrument. So now you have this relationship. We call this the this property. So let me save that. Let's try to see from the onto graph. So you can see here we have one all things with musician, musical instruments, and here is our property. So domain range from the musician to the musical. So those are the ways we visualize our properties in the ontology or in property. So that is also the visualize on this TTL. And if we want to do the TTL, so let's see here. You can load those properties with 5 triples. So showing here. So now it's every triple, the subject is the play instrument. And then let's add one triple to the end of this 040. So let me copy this 040 now. So 040 is on the 2, 3. So here. So that is we define a person, Richard Mart. So well, we will rename this, copy that to here and rename to 45. So add here. So AB plays instrument, AB vacuum cleaner, and then change this to semi. And when you want to query 45, you will have a list of those, and one of that is know the order first. So you may see here. So let's see which one. The first one is the play instrument. Now we give our object is the vacuum cleaner. In traditional object thinking, oriented thinking, if we say members of class musician have a play instrument property, this means that a member of the musician class must have our play instrument value. But it's different in this semantic web. RDFS and O approach this from the opposite direction. The last two triple actually of this 44. So let's back to this 44. This one means if something has RAB play instrument value, so value of this one property, then it has a member of class musician, and it has a play instrument value is a member of the class musical instrument. So that is the domain and the range, the definition. And once I've added a new triple shown in this 45, and RDFS aware the SPARQL query know that Richard Mart now is a member of the musician because he can play instrument of this one. So this is our instrument, the musical instrument. Let's see. So it's our individual. So we define that here is an individual by class. From the musical instrument, this vacuum cleaner is here, and we have our person. So person is have such kind of those properties, and those property are the data property, and we have our the name. So then if I create, let me see, we create our person. And this person we create, call this I0432. And we have some data property. So with the first name. So let's create our properties here. Data property. First name is one. Last name is another one. So I just showed these two, and then both of them, let's make sure is they are at the subproperty, and we come to our individual by class with this, and we add here the first name. By default, it's a string. We will use that, and it's Richard, and we'll add the last name. It's the string. It's the Mart. So now we don't say this I0432 is our musician, but we will define our object property. So it's the place. You can use this control space to auto complete. So we only have one place instrument property, so that is fine. So one cool. We only have our one the musical instrument. This field is read, this properties range. So they find this one as the only one. And now is you can see here, this person is just a type R person. But when I save this and I start to have the reasoner, so you can see here, this is the inferred relationship or inferred type. So that is coming from this. What we see is RDFS aware SPARQL processor. So this Prodigy is actually supporting this RDFS aware. So now it's because I defined the I0432 as has our play instrument property. So I gave a value, then they will infer or they will guess that through such kind of the different triples, they will appoint this person will be our musician. So that is the RDFS aware means. So if you also have a Prodigy, I suggest that you can also use this way to make yourself also clear to show this. So we have this person, and now I have this I42. So you can see here is this one is may also have a linkage to this musician, but we don't show the inferred relation on this ontograph, but you already can see here from the this person. So now you have that both within person class and the musician class. So that is the powerful things actually for the ontology or semantic web. They compare to the object-oriented certain language. Normally, it's those OOO, the language is kind of the closed word assumption. So if you tell this language something, define this class, they know that. But on this ontology, we base on the open word assumption. So you tell a rule, and we can infer certain things through the reasoner. Then that is the RDFS aware. It's probably going to be an O engine. All builds on RDFS, and not much software is available for support RDFS without also supporting the list sum of all. So Prodigy is supporting all, so you may find this that very easily to show you this inferencing relationship. So without define a large complex ontology, many RDFS developers use just a few class. So we just use like is the first name, last name, and we give some additional the relations. Then those are the relation we will try to let this ontology to guess or infer something. So it looks like it's from here. Let's typing this also as a practice. So we still have this same dot 45. We go to 44. This prefix are same. And now we have this I0432 is the first name, Richard. Oh, don't forget about the semicolon. Last name, not, and we gave us both. This is our property, so it's point to another IRI, so 9771. So it's done for this. So we have this 9771. So let's make that first. That is our knowledge. If we have, then we make that. It's a Cindy. Marshall. So they are suppose each other. Now we have this IA301, who is him. We will define correct. Patient. He has a relationship for patient. And then we define the relationship. Spouse is our property. So RDF type is all symmetric property. Let me show you that later in the property to do that. Comment identifies someone suppose. You can use a single quote within the double quotes. And second property is the patient. We see that is RDF type. Just our RDF property, and then RDF as comments. I will ignore the comments later on the demo to in the property to save time. And also we have a doctor. We don't see the doctor above, but we will see here RDF type, also our property. And RDF as comments. Identifies a doctor treating the named resource. And then this one is important things. Is inverse of AB patient. So if you do this arc command, you just have a lot of those triples. So let me see here, 46 now. Oh, line 22, undefined prefix. I didn't define that. So yeah, I miss one. It's all. I use namespace, but I didn't put in that. Come to here again. Let's see. So how many? So I have 3, 5. So first is the Mart last name, suppose first name, Marshall last name, first name, comments for suppose this one 2, and patient 2, doctor, patient doctor 3, and then correct. So all these we defined that. Let's now show you how these can be have the RDF the aware the. Let me back to the property. We define this in our ontology. Now I have several persons. So let's we already have a Richard. Let's add 9771, and then let's add also I Oh, sorry. So that is, I should add that as the not the class but the individual. So 9771, I should have the last name is Marshall. First name, you have to search some plugin to make you the type something easily, but let me do that just the menu. So crack to show you what you can do this from scratch. Last name is the Alice. So we have those names, things. Now we go to the definition of the object property here. So we have play instruments. Now let's create 3 more. Suppose, patient, doctor. So suppose is the semantic property. So that is the O part. So suppose actually is coming from here, character. So you click this, then that is defined the semantic. Semantic means is if A is the suppose of B, then through this is will be B is the suppose of A. So that is like this suppose definition. And then the patient. Patient is the property. And we have this patient is the inverse of property. You can define patient here is the inverse here. Or you can define from doctor. So that is for this sample TTL is coming from the doctor. We click doctor and click this inverse. Then it asks you to find another object property, click patient. So that we will do like this. But from here, you can see directly is the patient is also inverse of the doctor. So we control save. Now let's do the class individuals appointed. So we have I43432 is suppose with 9771. So we create this is the suppose and 9I771. So and if you click switch to 9771, you don't see that. You need to refresh, synchronize the reasoner. Now you can see here that is the semantic means. So because A is supposed to B, then now B is inferred to show you is the suppose of A. So let's see. So the crack has the patient of 9771, Cindy. So we come to A301 and have the patient auto select complete. So now you have this patient come to 9771. We don't have that. Now Control R is the synchronized reasoner. You see here. Now I know it's Cindy has our doctor of crack. So that is the visualized way for this the object property with this RDF as aware the SPARQL those processors. So as mentioned here. Until here, I show you the enough things is for these new chapters, sub-chapter actually. So we finish all these exercises all together, and I hope you get some ideas on how you can reusing and creating vocabularies by your own. I also demo to you is all these the TTLs have their relationship. We can build that in one ontology file in Prodigy. I also hope is you can practice that as well. And in next video, we will move to the 0205 is called the linked data. So let's have a quick way to understand what's the levels of the justification or the assessment of the linked data, the maturity. So see you in the next video. Bye for now.